Okay, so good evening. Can you hear me? Hello.
Yes,
Yes,
good
good
evening.
evening. Yeah, good
I
evening.
can hear you.
How are you? Are you
I can hear
okay?
you. Yeah.
Okay. Okay. Okay,
Fine.
so let's go. Basically, today I
Yeah,
will
I'm okay. Yeah.
try to discuss about the some advanced topic on GIS and cartography. How we can easily create the different types of map, mainly cartographic map, using R programming language. So mainly R programming in this time we are use, and then we try to discuss about the all of those things, all of those function, how we can easily use, and then create the different types of map for cartography. Okay, so let's go. Just I simply share my screen and try to show you that. Okay, can you see my screen now?
Yes. Yes, I can see. I can see it. It's loading. Okay.
Okay, so let's go. So basically, in this time, we try to discuss about these things. Mainly 4 days, we discuss about this topic. It's literally for the 4 days for cover all of those things. Mainly GIS, cartographic, and spatial analysis using RStudio, mainly R programming language. Okay, so all of those function, all of those advanced level cartographic map, how we can easily create using RStudio. I'll show you that all of those things from step by step. And basically, first of all, I will try to discuss about the some package, mainly library. So this type of library we are using this time for the different types of data manipulation and also different types of data visualization. This type of things we are use some different types of package. Okay, mainly it's a R package, and this type of package we can easily use, and this package help you to create the different types of advanced mapping or also advanced geospatial analysis we can easily do. So here you can see it's the one kind of package. This package name is that simple features for R. This package name is the SP package. Okay, it's called the SP package. Mainly, it's very most popular package for encoding of special data. We can easily handle the different types of vector data, point, line, polygon. We can easily use the SP package. So basically, this SP package is used for the encoding of special data. It's a one kind of package. So further, I also try to show you that how we can easily use this type of package using RStudio, mainly R programming language. In this time, it's one kind of package. It's called the SP package. This package we use for handling the different types of special data. Then you can see there is another package. This package called the raster. Okay, mainly raster for working with raster data, mainly satellite images. So raster is another package. Okay, so this package it's mainly work for with the raster data, different types of satellite imagery or different types of image. We need to use the raster data. Then you can see this is the another package. It's called the RGDAL. So mainly RGDAL provides the binding to the geospatial data abstraction library. So it's also a lot of use for that different types of mapping, mainly satellite mapping or satellite image mapping, where we use here the RGDAL, as well as also you can see the another library. It's called the RGEOS. It's mainly manipulation and querying of special geometrics using the GEOS geometry engine. Also you can see the map tools, so it's another popular library. So this library is popular set of tools for manipulating geographic data. Also you can see and the another shape files. Okay, so this is the another library or package. This shapefile package function for reading and writing history shapefile. Okay, so we already know about the history shapefile. So suppose you need the NESC shapefile, you can easily get the shapefile package. So this package provide you the history shapefile, and then we can easily use it, and we also edit this shapefile and create the different types of map. Further, also you can see this the another things, netcdf files. So basically netcdf, so it's one kind of data source. We can easily use the different types of data such as rainfall data, precipitation data, as well as also there are a lot of data set we can easily get as a netcdf file format. So for it, it's another package ncdf4. So basically this package working with netcdf files. Okay, basically netcdf files is the different types of data. It can be temperature data, it can be rainfall data, it can be different types of data we can easily get the from the netcdf files. And how we can easily get this type of data, I will show you all of those things one by one. So then I hope we can easily get all of those things. So basically it's a basic data manipulation. We are use this type of package. So simple feature of R, raster, rgdal, rgos, map tools, shapefile, netcdf4. So this type of package we need for the data manipulation. As well as also you can see the cartography and data visualization. So basically when you want to visualize your data, then we have to use this type of package. One package is called the ggplot2. So ggplot2 for creating the plot and maps use the grammar of graphics. So this is the another kind of package ggplot2. This package mainly we are used for plotting the different types of map, different types of chart. We can easily plot using the ggplot2. And then you can see R color brewer for use the color scheme created by, so it's created the Cynthia Brewer. So basically it's another package. This package used for different types of color scheme for your map. We can easily add the different types of color combination, and we can add the different types of color using the R color brewer. And also you can see the Vridis. So it's another popular source for the color plated. So basically this is the Vridis. It's another package. Basically this package is also useful for color plated. For the different types of color we can easily add in our map and create the very beautiful map using the Vridis package. As well as tmap. So it's the another package. It's the thematic mapping used. Suppose when you want to make the thematic mapping, then we can easily use the tmap package. Also you can see the leaflet. So it's another very useful leaflet. Mainly this leaflet we use for the creation of the web map. Suppose sometime you need to create some web map, so that's it's the interactive web map we can easily create using the leaflet package. So we can easily use the leaflet package, and then we can easily create the different types of web mapping for interactive map. As well as a map view, it's the another package. It's used for creation of an interactive spatial visualization with pop-up window for attribute data. So it's the another kind of package. It also help you to create the web mapping with pop-up windows for attribute data. Also cartography. So it's the another package, cartography name, for creation of cartographic representation with typical map element. As well as choroplatar, simplify the production of the choroplate map. ggmap, mainly it used for the web mapping with Google Map and OpenStreetMap. ggmap, it's another package. As well as special statistics, mainly special statistics we are used at this type of package, special. So mainly this special package used for creasing and point pattern analysis we are used. Then SPStat package for point pattern analysis. GStat package for modeling and prediction and simulation of the geostatistical data in 1 or 2 or 3 dimension we can easily do. Then SPDIP for creating for a special weight matrix. So basically also you can see this is the data source. Basically it's one kind of package. This package is stored the different types of data source such as Tigris. It's provide the cartographic files from the US census. Also you can see the tide census, access to the US census API from the American Community Survey, and then Denisial census. Also you can see the art, natural art, mainly it access to natural art data, different types of satellite images, different types of base map, we can easily get from the R natural art package. R is correct, but it's another package to access the Spirit Open Data portal. Okay, so basically this type of package we are used in this time. You can see there are a lot of package we already discussed about that, and this type of package will help you to create the different types of beautiful cartographic and also GIS spatial analysis using the R programming. Okay, so in this time, how we can start? So first of all, you need to download the RStudio. Okay, so how we can download the RStudio? So you can simply go to the Google and search here. Suppose R Studio. I simply search here. So here you can say I can get this type of things. RStudio desktop, download RStudio. So I simply click on the download RStudio, and here I can get the two file. You can see download RStudio. I can get download RStudio, or download RStudio I can get. So for desktop, so simply click on this download RStudio. So basically it's the free of charge. You can say RStudio or open source edition. It's totally free. Okay, but it also have some professional or also some cost. There can say they are also per year. They are take this type of fee. I can also, but it's also okay. There is no problem. In this time we can get this type of benefit when you are use this free version. But they are also at the more advanced data analyze in for their advanced for their premium or professional package. Okay, so in this time we are use here this RStudio for open source edition. Here you can see we can get this type of facilities, but when you want to buy it, then we can get all of those facilities. It also increase the more facilities because it is a paid version and it is the free version. So in this time we can simply download from here. Okay, so I already download these things. Simply click on here, then it will be start the downloading. You can see, and in this time here you can say I can get this type of things. In this time for RStudio desktop, first of all install R. Okay, so it's the R programming language, and it's the RStudio. Mainly in the RStudio we write our code. In R programming code we write in RStudio. Okay, so you can download and install the R. Simply click on here, it will be, you can see downloaded, and further you can see about that download R for Windows. Okay, download R for Windows. Click on here, we can get, you can see the binaries, and if you want to, you can see install the R for the first time. So for that you can simply use at this base, and you can say download the R for Windows. Download the R for Windows. Click on here. So now you can see it will be downloaded. Okay, started the downloaded. So I already downloaded it. This time not need to download again. And further also you can see download the RStudio. Okay, download the RStudio for Windows. So simply click on here, then it will be start the downloading for the RStudio. You can see start RStudio downloaded. So you can simply install these two files. Okay, then you are just check your desktop, or you can also check, suppose okay, just a minute. So you can simply check, you simply go to this Windows and simply search here RStudio. So here you can see RStudio. I already opened this RStudio. You can see it's the RStudio IDE. In this RStudio we can write only for the R code, R programming code we can write, and we can easily get this result. So you can get this type of things. Here you can see basically we can write our code in here. So just I simply click on the file, and you can see the R script. So click the R script. So now we can get this type of script. So basically in this time we can write our code in here. Okay, and we can get the, you can see the plot. Basically it show about the map. Also you can get the data. So here you can see I already add this type of map. Not only for that, we also create the more advanced top map. Create using the RStudio. I also show you that all of those things one by one. So I hope you can easily learn all of those things. So after installation, first of all you simply open the new window. So here I open this new window. In this time I need to install, suppose you can see this type of package such as SP package, raster package, RGDL package, RGOS package, map tool package, shapefile package, NCDF4 package. So this type of package I need to install. So how I can install this type of package? For installing this type of package, we can simply go to the RStudio, and further here you can see the package option. Okay, you can see the package option. in here. So in this time, you want to suppose install the any package. Suppose I want to install the SP package. So for that, I simply click on the install, and here you can see the package. So I write the package name. Okay. So suppose this package name is the SF. Okay, SF package name. So SF, and then I simply click on the install. So now this you can see it will be install this package. Okay, you can see it started installing. So install package SF. It show about that. Okay, you can see it's also working. In this time, you can see it show the red alert sign. It means that in this time it working. Okay, you can see it downloading all of those packages about the SF. So further, we can easily work with the SF, and you need to install for only one time. Okay, when you do that, then you don't need to install again and again. You can see it install it successfully. Okay, so here you can see it show about that package SF successfully unpacked. Okay, it successfully installed in this time in my system. So now I want to check it will be a successfully installed or not. Okay, so for that we are just use a function. Suppose I simply use a function import function. Okay, just I import this library. So just I simply use here a function library. A library, I simply put here the SF. So in this time, library, what is the library? Library mainly in Rstudio, we are used to import. Suppose you want to import this library, okay, SF. So just put here the library. After installing the package, simply use here the library, and then put here the SF. Mainly SF is a package. This package handle the geospatial data. So just I simply call the library and put here the SF. Okay, SF is a package. So now you can see the run button. Click on the run, you can see it imported. Okay, you can see it imported, and there is the no error. So it successfully imported the SF library. Okay. In this time, I want to work with that. Suppose in this time I just take a variable. Suppose
So what is the difference between the package and the library?
library mainly it's a syntax. Okay, library. Suppose we are in Python, we use the import function, import, and then put the package name. Okay, then put the package name. In this time in Rstudio, instead of the import, we use the library. Okay, library is a function. This function import the SF package. Okay,
Okay, so the function imports
this package.
the package.
Yes.
Okay.
And all time when you want to import any package, all time we are using the library function and then put the package name. And before that, we need to install this package. You can see there are a lot of packages we already discussed. I will show you all of this example one by one, so then you can easily get the idea how it will be working.
So it means when we have already installed the package,
Yeah.
and when we want to make another maps, we need to install the
No.
package again. Or
No.
we
No
install
need.
on.
No need. Install only for the one time, for the first time.
Okay.
Then when you
So
need
that
that,
so that
yeah.
you can have it, so that you can have it in your computer.
Yes. It install only for the one time. Further, when you want to use it, you don't need to install again. Just you simply put the library function and put your package name.
Okay, it will import this because it's already installed.
Yes, already install it in this package. Yeah. Okay. So in this time, suppose I want to show you a shape file. Okay. Suppose I want to show you a shape file, and further we show about all of those things one by one. So in this time, in this function, suppose let me check. Yeah. So in this time, I want to show you that how we can easily I take a variable. Okay, suppose I put the variable name is that suppose any name I can put. I put this variable name, suppose area. Okay, and then equal sign. this area variable, I want to store a shapefile. Okay, it can be any shapefile you can put, no problem. And
Okay.
suppose if you have any boundary, if you have already any boundary or shapefile, you can easily use it in here. So for that, suppose in this time, I just use the default shapefile. So for that, I use the st dot read. Okay, you can see it automatically show about that. SF basically it's a library. Okay, this it's a package. This package have a one function. It's called the stread. Okay, you can see it show the std. I can see it also get the your mainly what the tasks about this function. We can get the read simple feature or layer from file or database, stread. So it's a function of sf. Okay, and this function mainly read and read simple feature or layers from the file or database, and read simple feature from the file or database or retrieve layer name. So basically it's work for read only, display the shape file, display the feature, display the layers, st read. Okay, so in this time I use the st read function. I want to read this my shape file, and this shapefile I want to read from the package of sp. So for that I just simply use another thing. Suppose system dot file. Okay, you can see what is the system file. System file, it's a this is the find name or our system files. So just I simply click on the system file and then put the system file name. Okay, suppose I put this name is that chef, and it's the default, it's the already loaded this chef in the your sf package. Okay, but if you want you can also show the another chef file. I will show you the later how it will be work. ssp, and this chef file, mainly this chef file loaded from sp package. Okay, this package have already this name about this chef file. Okay, so now I want to use it, and then I will just show you that I want to read this file. For read this file, in this time I just use here the comma sign and call the package and put the package name. Package name mainly is it. Okay. So now I run this code. You can see it will be work. And you can see it show about the reading the layer NC from data source, is3 shape file, and simple features. We can get the 100 feature and 14 fields we can get. We can get the geometry type is a multi-polygon. We can get the dimension xy, bounding box, mainly this type of bounding box we can get from here. Okay, so in this time I just show you that all of this information about this file, and this shape file is mainly stored in the live package of sf. So now I want to, if you want, note the user will not use the system.file, just put the file name directly. Suppose I want to display the another shape file. Suppose I just simply show you that suppose my shape file I already downloaded, suppose from other sources. Suppose, okay, just I simply open my my local storage shape file. Yeah. So here you can see there's a lot of shape file you can easily get from here. I already downloaded. You can see this shape file, SSP is the shape file. When I want to show this shapefile, what can I do? Suppose my local storage shapefile, my local storage boundary, it is a shapefile. It is a shapefile. I want to show this shapefile in my using the SF package. Okay, I use the SF package and display this shapefile. So what can I do? Very easy. For that, first of all, you have to check your. You can see the files option. Okay, in this time here you can see the files option. Mainly when you click on here you can see that go to directory. You can see the directory. So this is your directory. Okay, documents. Okay, basically this folder documents, this folder connect with Rstudio. Okay, so click on here, we can get the folder is the documents. You can see basically this folder connect with your Rstudio. So in this time I want to, suppose I want to display this shape file. Suppose I want to display this shapefile. Suppose this shapefile I want to display. So for that, what can I do?
But
I
what about the shapefile that you have already import?
Yes,
This
yes.
in and you need to add another shapefile,
From my
right?
storage, yeah, from my local storage, I want to add the another shapefile.
But the one that you add is from where?
It's from this shapefile come from this
Yeah.
package, SF package. Okay,
The
it's
shape NRC shape file is it's a package.
yeah, it come from the package. In this time, I want to show you that it's come from my local storage. Suppose in my computer, I have a shapefile. So this
No,
shapefile,
this one I want to understand the one. Yeah, this one shape file NC dot shape file. Is it from where?
it's from your package. You can see the package SF. So this shapefile come from this package, SF
Okay,
package.
it's not the shape file that we have in our local drive.
No, 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 no.
Okay, it's just the imports.
Yeah, just
You want
import this
to
shapefile. Okay, but in this time, I want to import the shapefile from my local storage. Suppose this shapefile, I want to suppose this shapefile I want to import in my Rstudio using the SF function. So what can I do? First of all, I just simply copy. Suppose I simply copy this file, simply copy. Okay, and simply click on here and go to the documents file. So just I paste here this shapefile. So you can see, okay, so this my folder bzd. So now this folder, I just simply you can see the refresh, click on the refresh, and then find out the folder name bzd. You can see this folder, okay, which I put in here bzd. Okay, it's showing here because I add this folder in my documents. I add this folder in my documents. So all of those document folder show in here. Okay, so you can see this is the bgd folder. So click on here, and further I want to display, suppose this shapefile. Suppose you can see ssp. I want to show mainly, suppose this shapefile I want to show. Okay, this shapefile I want to show. So in this time, what can I do? Very easy. Just I simply take the another variable. Suppose I put the variable name is that, suppose bd. I put the, suppose Bangladesh. You can put any name. Bangladesh equal. In this time, I just call the stread. Basically, this function read your shapefile, and then further which shapefile I want to read. I want to read for that this to SSP. So for that, I just simply, suppose I click on here, and here you can see the BZD. I simply click on here, and further I just click on the open. So now I can get this. You can see it show about my or the file directory, C drive, users, Dell folder, documents, and my this folder. It now connect. So in this time, I just simply write the file name. Suppose I put the file name is that it's a BGD. Just I put here the BGD. Then put here a, just use the same name, ADM SC. Okay, and then use the comma sign and put the package. Just simply copy the same things from here. And now click the run. Okay, not really the same. Just click to the run. Okay, show the error. Bangladesh ST read. Okay. Okay, sorry. We have to also use the system file, this function file. Okay, just I use the same thing, simply copy and then paste here. I change the file name. In this time I use here this file. bgd. So remove the file name. It's this file name is that bgd. Then put here adm2 ssp. So now let's check. Okay, show the error dsn must point to source, not an impeding string. Okay, so let me check what happened. Okay, so st read, just let me check. We are just mistaking the unexpected error formation in Bangladesh. Okay. Just I simply copy this name from here. Okay, so the cannot open this file. This file does not seem to exist. I think some problem in the file directory. Okay, let me check. Suppose I want to work with for the watershed file. Suppose I just simply put here.
I wonder if we can use the directory as the directory to specify the path void
Yeah.
before the library before the library.
Okay, so now it's about that. reading the layer ROI from data source. Yeah, is the shape file. Okay, just I simply remove the copy this thing. Suppose copy. Okay, so it's already you can see. And this time it's about that. Reading the layer water from the data source. Okay, using history shape file, replacing null geometry with empty geometry. Okay, so now suppose I want to show BGD. So basically, first of all, BGD. Okay, so just I want to simply click on here and simply copy this path from here. Suppose simply copy this path, and then further I just simply put here this file name. File name is that suppose BGE ADM1.sh. Okay, so it show the G folder, G, but documents is BGD. Okay, this is the folder. Okay, copy. And now I want to just put here. Yes, now let's check. Or we can also do another thing. Suppose I just simply suppose this shape file. I simply copy. Okay, so all of those file I copy and go to the documents. And further I simply paste here. Yes. This one I added in here. So now I simply go to this Rstudio and then simply refresh it. So now I can easily get this type of file you can see in here. Okay. So now I can directly use it. Just put the file name. Suppose bgd admin. See. Okay. So now it's show about that reading the layer bgd data source. This is the data source. Okay. Yeah. Using the driver history shape file. Okay. So now it read the layer about that. Okay. Suppose in this time I want to discuss about. Okay. So now it's reading. You can see. Suppose I put at that 2 in this time you can see reading the layer do from data source. So this is our data source. Mainly it's our folder. Okay, document folder in here. The folder path it show about that. Okay, so in this time it read the file, and also you can see it also read the file for the another code. Okay, you can see reading the file nc data from it's also read the file, and it's loaded from that sp package. And this file which I put in here, my file shape file, it's loaded from my local storage. You can see reading the layer, the data source. This is the data source. It's the shape file. Okay, so now I want to suppose this type of file I want to plot in my map. Suppose default map I want to plot. For doing these things, we can easily do it for the plot. Or if you want, you can also do for that. Suppose I want to plot this area, then plot this Bangladesh, these things. So for these things, we are just use. Suppose I just put here the plot function, and suppose call this Bangladesh. I have to plot that. Click to the run or plot this area. Suppose area and run it. Okay. So now it will work about that. You can see it show about this type of parameter such as we can get plot this all of this plot show about from the shape file it come in here all of those things. Basically it's stored the different information. So in this time I want to work for the specific things. For that I plot this area and then I just plot the suppose only for the one plot. Suppose I put the one data or one attribute table data. I want to plot these things. So just put here the 1 comma 1 first column and first row about that, and then further I just put here the color. Suppose I put the color as a gray color. I simply put in here suppose gray, and add the true. Add the true, mainly it's add the legend. So add equal true. When I put the add equal true, it means that it add the legend of your map. So just put here the true. Okay, then click to the run. Now check what happened. It's working. Okay, so in this time, okay, layer is a demo. Okay, so it is a demo. It's about that. So this is a shape file. This is a library and SP. It imported, then imported the shape file from the SP. Okay, And further we are using this color plot, this type of plot, and then plot these things and plot these things like grayscale. Okay, so now we can, okay, so let's work here. So let's work, you can see. Yeah. So in this time here you can see, in this time we take the library sp, and now it's create the variable, and this variable is stored this shape file from the sp package. Okay, and further it show suppose this type of things. In this time it's go about that we can put the par, and you can see plot about that plot mainly nc1 and reset equal to false. Okay, as well as also put the plot color, mainly we can also add the plot color, this type of color, basically color gray, and we add. So basically when you add equal to true, it means that it add the legend about that. Suppose when you want to add the any legend on your map, suppose I remove the add, then you can see what happens. Suppose remove the add and true, then it's not print the legend. Okay, click the run, it not print the legend. You can get this type of things this time, not look at. So in this time we have to add the add equal to true, and plot these things from here. So now you can see it show this type of legend we can get. It show about that vertical legend in this time in here. Right? So in this time, we try to develop these things for our own data set. Suppose I have a data set, so this data set I want to use, and then try to make this type of map from our own shape file. So further, I simply open a new window. Suppose simply open a file and go to the Rstudio again. And in this time, first of all, I just simply, you can see, click on here, then it will be clear all of those things. Also, you can see the clear, then okay, I want to remove this current float, so it will be removed. Also, you can see, okay, I also remove. Also, you can see about that clear all floats. Yeah, so now all of the float will be clear from here. So first of all, I simply import the library mainly sf library. So we import it. Okay. Then suppose I just simply put the another things for the library. I want to use it, and then try to make the some map. So in this time, there's a lot of way to show this type of things. Need to load the data. So in this time, if you want, you can easily use your own data set and then try to load the data and use it. For that, you are just make this shape file about that. Any point or polygon or any boundary, we can easily show. Suppose I just simply go to the files. And suppose you can see this type of shape file I already imported in here. So now I just take a variable, suppose nc. . You put any variable name, no problem. And then further, just write the code, mainly SF is the package name, and put the ST, mainly read. Okay, and then put your DNS layer. So put your DNS layer. You can see we need the DNS mainly. It's the data source name. You can see DNS mainly it's the data source name. We put the data source name also in the layer. So just put the data source name. Supposing this time my data source name is that this is my data source. Suppose these points or any shape file. Suppose I put this shape file is that DNS name is the points dot SSP. So further, I just simply click the run. Okay, you can see it will be work. There is no problem. It show the reading the layer points from the data source, and you can see about that geometry type. It's a point shape file. Okay, so basically it's a point shape file. So it shows the point and dimension x y, and also you can see the bounding box. Mainly it's a bounding box. Mainly coordinate about that. Suppose in this time you want to just plot this point, so just use at the plot the MC. Mainly it's a variable MC. You can put anything and click the run. So now you can see it create this type of plot. You can see it's a point. It's a one kind of point or point. It creates the point. Okay. Suppose in this time I have to show the another file. I have to show the another file mainly this type of suppose this water. Okay, water is trying to show. So for that I simply use here the water SSP, and now click to the run. In this one I can get this type of thing. You can see it show about the water point. So basically it's also point for the water location. I make the shape file. So now click to the run. In this time it put the point for the water, as well as suppose I want to show any boundary. Suppose I want to make the boundary. Suppose I want to show this boundary. Suppose this admin. So I simply put this name in here. This name is that mainly underscore ad, it's a lowercase adm, suppose 0 adm 0, this shape file I want to read. You can see it will be read, and it show about the multi polygon. Okay, it's not a point, it is a multi polygon, and I want to plot that. Then check what happen I can get from here. So just plot. Okay, it working. You can see mainly it show about the working. It's a big shape file, so that's it takes some time for plotting. Okay, we can get that warning message. It show the plotting the first 10 out of the 7 attribute. Max plot equal to 70 plot all. Right. So in this time we can get, in this time what happen you can see. So basically in this time it's my column name. Suppose FAO local name ISO 3 object name 0. When I put here the suppose 2. Suppose when I put the 2, then you can see what happened. I want to show about, you can see I can get the total 65 feature. 65 features means that total 64 district in Bangladesh, total 64 district. So basically the district shape file, and we can get the 11 fields. So basically it's our column name. Suppose this file I simply open the QGIS and try to show you that, then it will better you can easily get the idea how it will be work. Suppose you can see at Bangladesh BZ, this file contains total 64 district in Bangladesh and contains 11 column in attribute table, and it's the multi polygon. Okay, so let me open it the QGIS software. Then you can easily get the idea how it will be work. What is the bit difference between that Rstudio and also difference between that QGIS. Okay. So basically this 11, this file, it's the attribute table column. This column add the different types of information, such as different types of population number or affected population number or anything, any information it can be added. We can easily add in the attribute table, and further we can easily use this type of information and make the different types of map in Rstudio. So let me open this map. some time. Let me see. Okay, opening. So in this time, suppose I just simply import this shape file. Suppose it's a bzd mainly 2. Okay, you can see this shape file. Okay, this file. Okay, this file I want to simply open in this QGIS software. Then we can see we can get the total 64 district. Okay, mainly it's the total 64 boundaries in Bangladesh. And click on the attribute table. Here I can get the mainly you can see how many column. 1 2 3 4 5 6 7 8 9 10 11. So in this time we can also get, here you can see the 11 fields, mainly 11 column on my attribute table. Okay, and it's about the 65 feature, mainly it's the 64 feature, because it start the counting from 0. So now I plot that. Suppose I simply plot and then check what types of plot we can get from here. So you can see it will be plotting. Okay, just a minute, working. So here you can see it plot this type of things. Okay, so first of all, here you can see mainly this name 2, name 2, this name 2, it's a column. Also you can see id 0, it's the one kind of column. So that's why it make the print for id 0, id 0. Okay, id 0. ISO, so it's the another column. So here you can see ISO, it's another column. So that's why it make the another map. Name 0, so you can see name 0, name 0, it's another. id 1, so it's the another column. So in this time it show display all of those column display as a layer. Okay, suppose IDO 0, ISO, NA name 0, ID 1, name 1, ID 2, name 2, type 2, all of those column it show. Okay, but it show about the different types of district. Name 2, name 2 show the different types of district. Okay, suppose in this time I just simply call the NC. Basically it's a variable name. I call the NC and run it. In this time you can see what happened. I can get this type of information, such as the attribute table. We can get from here. We can get the mainly simple feature collection, 65 feature, and 11 fields, mainly 11 column. We can get the geometry type as a multi-polygon, dimension XY. We can get that first 10 feature. So mainly you can see IDO, ISO, column name, name 0, ID 1, name 1, ID 2, name 2. So all of those things we can easily get from here, my attribute table. Okay. Also you can see about that all of those district we can easily get from it. So it's the provide the information. Basically this shape file is stored in this variable, and when I plot this, then I can get this type of map. From here we can easily filtering, as well as we are also get the information about these things we can easily do. So it's a one kind of way to read the shape file. And mainly sp function, sf function, it's read your shape file. Mainly your any kinds of geometry file. It can be point, line, polygon, this type of things. It will be read and visualize this map. Time, suppose I want to check about the coordinate reference system before transformation. It is also possible to check the, suppose I just simply call the SF, and then we can easily check about that what's the coordinate system about that. All of those you can see it already show about this type of bounding box about that. 88 degree 01 minute to 20 minute 74 second, also 92 minute 66 minute second, or 26 degree 63 minute. We can get the georeferenced information about the specific coordinate about that. Suppose in this time I just show you that class function. So suppose in this time I just put here the class and call the nc and print that. In this time we can get the class about this in this data set. This data set mainly it's a data frame. Okay, you can see it show about the format, it show about the data frame. As well as suppose I just simply use another function, head function. Head, I want to show only for the head about the nc. Basically nc is stored in my shapefile. Nc, I simply click to the run. In this time we can get the head about that. All of you can see mainly it's the head about that. It show default mainly you can see six information, mainly six row it show about that. Suppose you just put here that you can put another thing as a number n equal to suppose 3. So now we can get only for the 3 information in here. So we have to use the comma sign, so just use the comma and then further click to the run. So you can see we can get it only show about the 3, 1 2 3 information. Because I defined the head, I call this shapefile variable name and put n equal to 3. Then I can get only for the 3 value or 3 row we can get from here. In this time we talk about the suppose area measurement, how we can easily compute the length of line or compute the length of polygon about that. So for that suppose in this time I just simply use the function mainly sf I call and then put here the sf suppose sf sf it's called the st length, sorry, st. Suppose area, I have to measure the area. Compute the geometric measurement, st area. So then I simply call this nc because it stored all of those boundary. And now click to the run. So now you can see it can compute the area in meter square. Okay. So how much area for total 64 district, we can get that how much area in this time in here. Okay, so 1 to 65 it show about that area. So basically it's another function st area which is mainly calculated the area for each feature or each geometry we can calculate the area. In this time suppose here I can get this type of things. Suppose here you can see I want to show only for this map, I not show all of those map, I want to show only for the for this district map or separate this map. So how I can do that? Very easy, just I simply plot only for the single map. So use that the plot function and for that I just simply suppose I just call my nc because it stored all of those map. I just plot in this time only for the one map, so just use nc and further I just simply put the square bracket and I put the name2 because name2 represent this map, so I put here the name2. So plot, put here the name name. So now further I just simply plot that, suppose plot. Okay. So now you're gonna see in this time it show about the only for the name2. Okay. So now if you want you can also add here the legend as well as suppose basically it display about this result. Suppose I just put here the add, put here the comma sign and add equal to So now let's check what happened. Okay, it's working. Okay, I think it's a lot of total 64 district. So that's why it not make this type of mainly release and it's not create because it a lot of place for need that. Okay, so suppose you just put here that suppose in this time how it will work. Suppose in the attribute table you just add any information. Okay, it can be affected people, it can be suppose your dead people or affected people. Any information you can easily add in your column. Okay, and this column you can simply put this name. Suppose when I put this name to column, then it display about the all of those district boundary it show. Suppose any information you can easily add in here. Suppose I show you the another example from my another data set. Okay, just okay, let me share this information. Suppose here you can see this is the country shape file, and this country shape file contains a one information. Just I open this shape file. Suppose is the Bangladesh shape file. Yeah, so it's simple open. In this shape file, we can get one information in the attribute table. Here you can see the open attribute table. Here I can get the one information about that population density. Or not here. It's not. Just a minute. It's not. Okay, just a minute. I try to find out this data. Is it? I don't know where is the data. Just let me check. We're not sure the another example is not showing. Okay. Suppose in this time here you can see it's one kind of column. It show about the district code. Okay. So I want to make, suppose it's one kind of any kind of information. Okay. So now this information 1, 3, 4, 6, 9. Suppose it's one kind of information. This information you want to represent on this map. How I can do that? So first of all, you just simply import this shapefile in your ArcMap software in Rstudio. So I simply copy this shapefile and click on here. Mainly just click on here, your file directory. Go to the files and click on the directory. And further, you are just paste here, paste. Okay. So in this time, I want to work with this shapefile. So for that, copy this file name from here, copy, and further just refresh it and try to find out this file name. You can see this file name. I want to refresh. So in this time, I just simply put in here. Okay. And further, we are just put here the Bangladesh shapefile, and now click the run. It will be work. You can see, and plot that. We can get the plot. Okay, it will be plotted in here. It is some time. Okay, so here you can see it make the plot. We can get this type of plot. Okay, this code, it show about the this code. Okay, this information at, and we can make this map. So in this time, we mainly in this shapefile you can get the two information, this code. So for that, first of all, you can just simply put here the this code. Just code, and now further run it. So now it's working. Okay, it's working. Yeah, it's some time. Okay, so now we can get, you can see. So now we can get this type of legend also in here about this map. So in this time we can get it's a 20. So this type of color is the less than 20 we can get in here. This color identify about that. Okay, so this is the legend about that. So now further you just simply export as a image or PDF. You can easily export. Suppose I export as a image. Now you can simply can see different types of format you can easily use. And then further file directory where you save it. So we're going to save another desktop. Desktop I simply select and open. Further I just save it. So now it will be saved. Okay, so basically in this time I simply open this map and show you that how it will work, how it look like. Okay, so we can get this type of things. Okay, map. So basically this is the SF package, but there are a lot of use. Okay, so further next class I also try to discuss about that how we can easily work with SF function and create the different types of beautiful map. And I also try to complete all of those packages which I show you that. And basically this is the online training program for the GIS and cartographic spatial analysis with R programming. Total duration only 4 days. In this online training program I will try to cover all of those packages and how it will work for that GIS and cartographic and spatial analysis. Okay, so anyone, if you are interested to join this online training program, you can simply contact with me, then you can easily join, and then you can easily learn all of those things for the GIS, cartographic and spatial analysis tool. Okay, so today is no more. Thank you for watching that.